Hey, 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 we're having fun with radicals in Algebra 1, adding and subtracting and multiplying. So, let's say, for example, you have 3 of these blue fuzzy guys and 2 of these purple fuzzy guys. Well, along come another couple of blue fuzzy guys and 4 more purple fuzzy guys. Well, how many total blue fuzzy guys are there? There are 5, that is correct, and there are 6 total purple fuzzy guys. Alright, so 5 blue guys, 6 purple guys. Instead of using a picture of the blue guy, I could just use B as a variable. 3 of the blue guys and 2 of the purple guys. And along come another 2 blue guys and 4 purple guys. And so we have a total of 3B plus 2B gives us 5 blue guys and 6 purple guys. Right? This is how it works with variables combining like terms. Well, much the same when we're working with radicals. You've got 3 of these guys and 2 of these guys. 2 more of these first guys and 4 more of these purple guys right here. Okay, so 3 radical 5s and 2 radical 7s. Here you have another 2 radical 5s and another 4 radical 7s. So you have 5 radical 5s and 6 radical 7s. That's about all there is to that. So, in summary, radicands must be alike in order to add or subtract. Kind of like in monomials. Kind of like when we're adding and combining like terms. So, 3x plus 4x is 7x, right? Same variable. We can add them. 5 radical 2 plus 3 radical 2. We're not multiplying them. We're just adding them. That's 8 radical 2. Nothing changed with a radical here. Right? Same thing, adding or subtracting. Works the same way. 5 plus 7 is 12. 12 minus 6 is 6. 6 radical 2. Now here, notice we have a 7, radical 7 here, and a radical 7 right here. We can combine these two. We can combine the radical 11s. Okay, so that gives me 14 of the radical 7s and -1 radical 11. Now I don't have to write that 1, so that would just multiply in and give me just minus radical 11. Alright, now sometimes you'll run into this and see, okay, well these have different radicals, so I can't add them. Well, first see, is there anything you can do to simplify those radicals? Remember, 18 is 9 times 2. 32 is 16 times 2. 72 is 36 times 2. 9 is a perfect square, so I can simplify that. 16 is a perfect square, so I can find the square root of that. 36 is a perfect square, so I can find the square root of that. So now we have 2 times 3, radical 2, 2 times 4, radical 2, and 6 radical 2. Simplify this expression. Now they all have the same radical, and so I can combine them. Gives me 20 of those radical 2's. Remember, radical 2 is an irrational number. It never ends. It is a never-ending decimal, not a repeating decimal. Alright, to multiply radical expressions, and we've already done this, kind of like we use commutative property. I can multiply 3 times 2, that gives me 6, and then 2 times 6 would give me 12. However, radical 12 can be simplified. It's 4 times 3, and 4 is a perfect square. So I can pull that out. Square root of 4 is 2. Multiply that, and gives me 12 radical 3. Okay, quick review from the previous lesson. Alright, we're going to use that here, and this works just like distributive property. If this was a and this is a, then we'd have a times a gives us a squared. So 3 times 2 still gives us 6. Radical 5 times radical 5. Now we're multiplying, so that gives us radical 25. Okay, this is a multiplication. Distributive property here, that's a multiplication. So now I'm going to do 3 times 5 gives me 15, and 5 times 3, radical 5 times radical 3 gives me radical 15. Next, check to see, is there anything we can simplify? Well, here we multiplied a radical with itself. Technically, that just cancels out the radical. So square root of 25 is 5. So 6 times 5 plus 15 plus radical 15. 6 times 5 can be evaluated. 30 plus 15 radical 15. Can we add these two? No, we cannot, because there's a multiplication right here between 15 and radical 15 that would have to happen first before adding, and so this is simplified. All right, you'll see this kind of a problem here. Find the area of the rectangle. Well, you know area is length times width. We can call it base times height, length times width. Pretty much the same thing. So we have to multiply this times this. Okay, now what do you notice? Okay, we'd multiply, we could use the beast box method, right? So we can multiply using the FOIL method, this times this, this times this, this times this, this times that. That's one way to do it. Another way to do it is use our box. Do 5 radical 2 times 5 here. 5 radical 2 times 4 there. Negative 3 times radical 5 here. And negative 3 times radical 4 in the last box. Okay, we'll look at the linear way of doing this one since it's two binomials. 5 times 1 is 5. 2 times 5 is 10. Plus 5 times 4 is 20. 2 times 3 is 6. All right, that was the first one multiplied with each of the second one. Now we take the second term, negative 1 radical 3 times 1 radical 5. So 3 times 5 is 15. And then negative 1 times 4 is negative 4. Radical 3 times radical 3 is radical 9. All right, now we've done all the multiplication. Now we check to see is there anything we can simplify. Radical 10, that's just 2 times 5. Radical 6, that's just 2 times 3. Radical 15 is just 3 times 5. However, here we have radical 9, or square root of 9, and that is 3. So we can simplify that one. That gives us 12 there. And that is it, ladies and gentlemen. That's all the radical fun we're going to have today.